Okay, so let's get started. We're going to be taking a look in this training module at setting up and configuring and tuning with our normalized knock strategy. The last tutorial we went over the idea of the normalized knock strategy and went through some data log examples. Those examples were using a flat response knock sensor. They were not using a resonant style knock sensor, which are more inherently noisy compared to a flat response. We're going to be taking a look at this tutorial, kind of the worst case scenario. So it's going to be a resonant OEM style knock sensor. We're dealing with a Honda high compression K24 engine, and we're going to be doing this calibrating and tuning process on our spark timing table and setting up our normalized knock strategy at the same time. A lot of the settings and configuration details for the normalized knock mode will change based on whether you're running a flat response sensor, which is quiet, definitely a lot better to work with this normalized mode, or working with a OEM resonant sensor that's going to be noisy. We have to be careful of how we set things up. We have to give the knock strategy a lot more leeway in terms of raising up the knock threshold because it is, again, going to be inherently noisy. So when the normalized knock mode is looking at each previous ignition cycle and what the knock sensor was outputting, recall it always compares the current knock levels and the knock output compared to the past previous few cycles, it can be problematic because we can get a spike in the resonant style knock sensor output just based on noise. So it's the normalized mode definitely works better with a flat response, a much quieter sensor that's a little bit more accurate, but we can still make it work with a resonant. So I'm going to go through the tutorial, worst case scenario, resonant sensor, setting everything up, and just watching the tuning process. So this, our in-house test vehicle, EP3 Honda Civic, we have it strapped right now onto the Mainline chassis dyno. We will be referencing the Mainline chassis dyno screen as we're doing the calibrating and tuning process, just so you can see some of the power gains as we're adding our spark timing in. We're starting off with a very conservative spark timing table on purpose because we need to have a baseline to figure out our map threshold raise, our load threshold raise, TPS threshold raise, RPM threshold raising, and then the actual knock threshold that we need to set in our tables. We need to make sure that those are accurate with a conservative spark timing where we have no knock. Then we can start to tweak and adjust those a little bit. And I'll just kind of go outline this process so it makes a little bit more sense. All right, let's jump in and talk about our spark timing table first. That's the very most important thing that we have set up before we do any actual tuning in terms of our spark timing or even the knock. We need to have conservative spark timing so that we have everything kind of in a safe running condition and we can get our baseline to set up the normalized knock mode. All right, let's move from our basics page over here to our spark page. Now in this page, we're gonna find our ignition table 1 here. Ignition table 1 is set up based on map pressure versus engine speed. Now this is set up for the engine I'm working with. We can see the brake points are going out to 8,000 RPM and the maximum load brake point is 100 kPa. This is the naturally aspirated engine, so we don't need to go and scale anything much higher than 100 kPa or atmospheric pressure. That's at sea level. I'm at approximately sea level right now. Let's talk about our values in the table. So this is a higher compression engine. It's about 12.5 to 1 compression engine. The values that I'm having in here in part throttle, probably bump them down to something like 25 degrees. Idle, we have our timing here at roughly 15. Full throttle, we can pull our values down. That's 80 to 100 kPa. We want them, let's say high RPM here, roughly 14 degrees of timing. I'd expect the ignition timing to be anywhere between roughly 22 to about 26 degrees for this engine. So I'm going to be cutting my spark timing down about 8, 10, 12 degrees less than where ultimately the engine is going to end up with its spark timing so that we can baseline things with no knock. So we're pulling our spark timing down pretty low here in part throttle. 25 degrees should be safe for any engine, even if it's high compression like this engine, for running your spark timing at. We'll go from 1,000 to 3,000. We'll do Shift H. We'll just bump that spark timing down. And then we're going to go here from 30 to, let's say, 100 kPa or 30 to about 80 kPa. And we're going to go across here and do Shift V and just bump all the timing values down in the table. Again, full throttle conservative timing, part throttle conservative timing. This allows us to focus on the normalized knock mode threshold setup. We need to go and define everything around an engine, the knock sensor output for the engine we're working with. So we're dealing with a loud, noisy knock sensor and an engine that is built, so it's probably also going to be loud and noisy. We want to make sure that we're not falsely registering knock and having the knock control work in overtime. The other thing that I want to do here before we even jump in to take a look at setting anything up for the normalized knock mode is to make sure we're going to be using the onboard logging to take a look at this normalized knock strategy. The onboard logging is needed because we need to log at high speed. We want to sample at not 50 hertz, but something like 1,000 hertz to take a look at this data here for the normalized knock mode because it moves extremely quick and we don't want to miss anything in its strategy. If we're laptop logging, a lot of times we can miss any kind of spikes, any kind of output deviations in the knock sensor within the normalized mode. So if we go here to logging and we go up here to setup logging, in the ECU logging, I have defined and set up everything here, all the important channels I need to use. Specifically looking at our knock control, I have all the channels here set up for 1,000 hertz, so high speed logging, as well as any of our normalized specific channels. We're logging at extremely fast logging rate. So anything that's important, that's fast moving, I am logging that at 1,000 hertz. Important for taking a look at the data and evaluating the system. You can go here, if you go to load, I actually have that file saved in our course folder. So go to the course packet, go here to onboard logging templates, and we can see here that's going to be the onboard logging knock. That's the option that you want to go ahead and choose. So just keep that in mind. That will be available for you. That has all this populated, so you don't have to do all that work. All right, let's click cancel.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.